Alright guys, welcome to the new video again. In this video we will discuss some new topic. Topic is, wait a minute, principle of inclusion and exclusion. Alright, note, sorry guys, this is not the topic. We have already discussed this topic. So now topic is pigeonhole principle. Pigeonhole principle. So what is this pigeonhole principle states? So uh, there are some keywords related to pigeonhole principle as at least, right? At least how many or and at least how many. This is the and minimum how many. Ways like that. These are some keywords, key statements you will find in the questions related to pigeonhole principle. And there are two types of pigeonhole principle. Uh, One is basic and second is advanced. Right. So basic pigeonhole principle is state that if n pigeons occupy n pigeonholes and n is greater than m, then at least one pigeonhole will have at least two pigeons. At least one pigeonhole will have at least two pigeons. So let's say for example we have four pigeons and three pigeonholes. So these are one, two, three pigeonholes. So pigeon one, pigeon two, and pigeon three, one by one. Alright. But where can we we have to put pigeon four in one of them? Alright, one of the pigeonholes. So one of the pigeonholes will have then two pigeons. This is the definition. But there is a catch. If we have five pigeons and four pigeonholes, pigeon PHP hole, then exactly one pigeonhole will have uh, two pigeons. This is wrong statement because Uh, this is also possible. One, two, three, four. These are some holes. Pigeon one here, and pigeon two also here. Pigeon three, pigeon four also here. With pigeon five here. This is also a right arrangement. All right. So this is not stated exactly case. I only said at least case. Oh my goodness. Oh my goodness. This only states at least case, not the exact case. Right? This is not like we have to fill all the holes first, then we can fill the start filling the other holes. So that vice versa. We can fill put all the five pages in one only. So this says only says that at greater than two, at least two pages will be. Uh, this is also right. P1, P2, P3, all in one hole. P4 and P5. This is also correct. Right? So yeah. Now next question here is would be if we have if we have identical pigeons and distinct holes, pigeons and distinct holes, then it becomes distribution problem. Let's say we have n and n pigeons, it becomes m1 whole h1 plus h2 plus dot 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 plus hm is equal to n holes. We have this is become distribution problem. This is n is equal to m and r is equal to n here. N minus 1 plus RCR formula is the quiz. Alright. This is how we do this. Alright. Next note here is in all these 56 ways, in all these 56 ways of distribution, there are uh, at least one whole which has two or more pigeons, right? Right. Question here is next question is if pigeons and owls are distinct, number of ways is equal to if pigeons and owls are distinct, so number of ways and m. So there m holes, alright, or we can say there n pigeons and m holes. It has m choices. This is also m choices m to power n. Right? This is how we do this. Where all these right, yeah. This is the process. So next is advanced pigeon principle. This is advanced What the hell? Pigeonhole principle. Advanced pigeonhole principle. If n pigeons occupy m pigeonholes, right, and n is greater than m, then at least one pigeonhole will have at least n by m or n minus 1 by m plus 1 pigeons. At least one pigeonhole will have at least n by m means function. This is advanced one. 5, 4, 1 point something something equal to 2. Or we can say n minus 1, 4 upon 4 plus 1, 1 plus 1 is equal to 2. This is the case. So we will do some questions here. Let's say this is the question. At least 5 pigeons is same pigeon in same pigeon hole, then total pigeon hole are at least how many pigeons are there? 5 by 5, 1. What the hell? At least 5 pigeons in same pigeon hole. Total pigeon holes are 5. Right. So what is the question say? At least 5 pigeons in the same pigeon. At least 5. Right. This the value is 5. And well, there are 5 pigeon holes are there 5 at least. Pigeon holes are 5 only. Alright. M by 5. That's n by 5. 4. Next trick is last this n minus 1 about m is equal to 5 and plus 1 is here. So m is 5, 4 here. M minus 1 is equal to 20, n is equal to 21. This is the answer. Right. Next question is, next question here is, if 50 bicycles are painted with 7 colors, at least how many bicycles have same color? So how many bicycles are there? 50. And how many colors we have? 7. 8. It is the answer. Next question is, minimum how many bicycles if they are painted with 7 colors and at least 4 bicycles have same color? At least 4 bicycles. So n minus 1 by m plus 1 is equal to 4. N minus 1 by 7 plus 1 is equal to 4. Minus 3 n is equal to 22 is the answer. Solve this. Next note here is some note. When in question there is keyword minimum, at least how many, solve it by pigeon hole principle only. Let's say this is the question, new question. Minimum how many cards must be picked from deck of 52 cards so as to guarantee that at least 3 cards are of same suit. Three, that at least 3 cards are of same suit. Question here meaning how many cards must be picked from deck of 52 cards for a PJ guarantee at least 3 cards are of same suit. So there are 52 cards, right? And there are 30 is equal to 4 suit or 4, right? 4 suit. So n minus 1 upon m plus 1 is equal to 3. N minus 1 upon 4, 2. N is equal to 9. 9 cards will be and card we have to quick. Right. Category 2 here is very good question that previous one. Question is, if every possible community of 3 boys and 2 girls from 10 boys and 5 girls is written and on sheet of paper, and the sheets are distributed in 4 heads. One of these head will have at least how many sheets? Bar of sheets, number of community, bar of 7 sheets. N is bar of 0.4 300. No, at least 300 sheets. Category 3 here, then category 4 also. What a game, bro. It scam. Category 3 of question. Question here is, if pair of distinct numbers are chosen from, if pair of distinct numbers are chosen from 1, comma 2, comma 3, 10, then at least how many pairs have same sum? Have same sum. Chosen from this, then how at least how many pairs have same sum? Right. Your distance now 10 C2 45. Alright. Whatever pairs are there. Then what we will do is pairs are like this: 1, 2, 1, 3, 1, 4, like that. It is 3, 5, and so on. 9 to 10. These are the pairs. 19. These are the sums. How many sums are there? 19 minus 3 plus 1. 17 are sum. Total number of sums are 17. Division is also 45. 45 on 17 different types of sums. The same sum would be like total 5 is equal to 3 is the answer. Alright, this is the case. Next question here is, if pair of numbers are chosen from one trend, then at least how many pairs have same sum? Alright, 1 to 1, 2 to 55 sums are there. Alright, repetition, no, this is x1 plus x2 plus x3 plus x10. 2 is what? How many ways we do this? 1, 2. Both of them here. Here only the distribution. 19. 1, 1, 20, 17 is category 4. 4 category type question. Let's say we have 10 pair of red shoes and 15 pair of green shoe, 12 pair of blue socks or shoes. So in the basket, minimum number of socks are drawn to guarantee that we get a match pair. Alright. 10 10 is there for 25, 12, 37, 7, 38. Yes. Career software. If path identical, If pairs are identical, 3. Fourth term will be there, the right answer. Next topic here is we will discuss. Wait a minute, guys. I'll be right back. I will take some water only. Then we will continue. Alright, guys, welcome back. We are back with a new topic. New topic here would be like new topic is introduction to binomial and multinomial summations. summations like this. So formula for this will be x plus y to the power n. This is binomial, right? X to summation of r is equal to 0 to n NCR x to power r y to power n minus r. This is a generalized formula. It has some variations, so it would be like this: NC0 yn plus NC1 x y to power n minus 1 plus NC2 x square y to power n minus 2 and so on. NCn power n y plus 0. These total are n plus 1 terms. Alright, which means if n is equal to 2, total number of terms is 3 terms. We already knew it. Alright, for example, this is the case: x minus 2y to power n is equal to NC0 x to the power 0 minus 2y to power n plus NC1 x to power 1 minus 2y power n minus 1 and so on. This is the case. So first question for us from this will be x plus y to the power 10. So find coefficient of x square y8, which means r is equal to 2 and it will be 10c2 x square y to 8. 10c2 is equal to 45 is the answer. Now next question for us is 2x minus 3y to power 10. Find coefficient of x cube y to 7. It will be 10c3 2x to power 3 minus 3y power 7 will be 8 into minus 27 into 10c3 is the answer. 3 to power 7, it is 3 to power 7 minus is y. So next question for us is this is x square plus 1 upon x cube to power 10. Find coefficient of x to the power 5 and comma x to the power minus 6. So this is about x to the power. How can we do this? We know NCR x to the power right to power n minus r, right? Equivalent to x plus y to the power n. Alright, but here is what is going on. NCR x to the power 2r because it is x square here and y to the power minus 3 of n minus r. Just like that, right? It is like NCR x to the power 2r x to the power minus 3 n, what is it? 3n plus 3r It is NCR x to power 3m 5r minus 3m. So it will be like 10 CR 5r x power minus 30. 10 is here. 10 C7 power 35 minus 30. 10 C7 power 5. So 10 C7 is the answer. For x to the power minus 6, what will be when I equal to 6, 0 to 5 is equal to minus 5, is equal to 4 minus 10. Can't get minus 6, 0 due to combinatorics. Answer will give answer 0x. Can't get 0x. Alright. Multinomial things will be begin here. X plus y plus z power n is equal to n factorial summation of n factorial upon n1 factorial n2 factorial 3 factorial where n1 plus n2 plus n3 is equal to n. Next is x plus y plus z plus w to power n to summation of n factorial upon n1 factorial n2 factorial n3 factorial n4 factorial where n x to x power n1 y to power x to power n1 y to power n2 z to power n3 n2 z to power n3 w power 4 where n1 plus n2 plus n3 plus n4 equal to n. Here will be question for this is x plus y plus z is to power 10. Number of terms will be n1 plus n2 plus n3 equal to 10. Next, this can be solved by minus 1 plus RCR for us 3, 7, 2, 12C, 10, 12C2, 66. The answer. The question. How many terms are there? These are the terms. Cos these are the terms. All right. X plus y plus z to power 10. Find cost of x square 3y5 equal to sigma n factorial upon n1 factorial n2 factorial 3 factorial x to power so like 10 factorial upon 2 factorial 3 factorial 5 factorial coefficient of x2 y3 y5. This is the answer. All right. Next question is 2x minus 3y plus 4z to power 10. Find coefficient of x square y cube z 5 y z is there and factorial 1 factorial 3 factorial 5 factorial 2x to the power square coefficient. This is the answer. And coefficient of x 3 10 0. So, question f n1 plus n2 plus n3 greater than n then 0 solutions. Some properties of we will discuss some properties of binomial coefficient of binomial coefficient. These are some properties, general properties we are going to discuss. One is NCR is equivalent to NCN minus R. We already discussed it. Second is NCR is also equal to N minus 1 CR plus N minus 1 C N minus R minus 1. Wait a minute. R minus 1. Pascal formula, it is called Pascal formula. Third property is NCR into RCK is equal to NCK into N minus K CR minus K. This is Newton's formula. Newton's formula here. NCR into RCK, NCK into N minus K CR minus K. Fourth property is sigma of R is equal to 0 to N, NCR is equal to 2 power N. This is row sum. Next is sigma of R is equal to 0 minus 1 to power R, NCR is equal to 0. Alternating sign row sum. 6. Even sum and odd sum. NC0 plus NC2 plus NC4 is equal to NC1 plus NC3 plus NC5 and equal to 2 to the power n minus 1. Right? Seven. Row sequence sum. Row sequence sum is sigma I is equal to 0 when NC0 square equal to 2n Cn. This is like this. NC0 square plus C1 square like that, 2n C. Right? The next property is here, column sum. Sigma NC k is equal to 0, KCR equal to n plus 1 CR plus 1 into 0 CR plus 1 CR like it, n plus 1 CR plus 1. It's called column sum. Ninth property is sigma r is equal to 0 to infinity. R into NCR is n into to the power n minus 1. Second is r is equal to 0 to infinity. 0 to n, not infinity. To n. R square into NC n r NCR equal to n minus 1 to the power n minus 2 here. Right? Number 10 property is r is equal to 0 to k m c r into n c k minus r is equal to m plus n c k, all plus. Okay. Right. Thank you so much, guys, for watching the video. And next we will discuss some. We will start new topic called generating functions. Hope you are doing well, and then we will discuss some more topics. Thank you so much, guys, for watching the video. After generating functions, we discuss recurrence relation, and then after recurrence relation, we will start set theory, right? And then closure thing, property and parameterization of functions. Then we will discuss further. Thank you so much, guys, for watching the video, and see you again.